share different set of notes. Yeah, so I was saying that we have two types. We have open model and we have closed model. So the producers, we have the we have the producers and we have the destination. So the output of each industry from each industry is either taken to final consumption or becomes an input of the subsequent sector of the economy. So this shows the interdependency that we are talking about. Well, for this to hold, we have what we call, or the reason why we are doing all this is to get what we call the technical coefficient. But before we look at how we derive the technical coefficient that will be used to show the interrelationships, the assumption of input-output model is that all the input in the economy emerges as outputs. So it's an assumption because we know, for those who have taken process accounting in cost accounting, we have wastage, we have work in progress, we have wasted man hours. Sometimes we experience abnormal losses because of some eventualities like machine breakdown, etc. But in our case here, for the process or for the coefficient to work, we assume that input equals output. Then secondly, industries or the sectors of the economy are assumed to be interlinked and they interact to produce outputs with the sectoral output acting as inputs in the same or other sectors. So again, it's an assumption that process A output becomes process B input. Process B output becomes process C input, right? So I've said that we broadly categorize this into two. Open is where we are consuming and we are extending the use to the other sectors of the economy, and closed is where we are producing for our own consumption. Now, the real thing or the reason why we are doing this is to help come up with that technical coefficient that will be used by the economists for purposes of planning. And you know, when the government is planning, they plan for the entire population. Although we know it's not the entire population that is producing. Actually, some people are unemployed. Some people don't even have food, leave alone being productive. So we are talking of a situation where the technical matrix, yesterday I was looking at the CS Treasury talking about the growth index being 10.1. And I was asking myself, where is that growth? Because from my knowledge, or as far as my knowledge goes, I would say the economy has shrunk, it has contracted. We are even in a worse off state than where we were during the post-corona period. And if we were at 4.7, and we are talking of a double digit of 10.1, then I don't know. So to me, I think that is PR gimmick. But again, I don't have data. Neither did he share any data. So the reason why we'd be interested in data is for purposes of genuinely defending our stand. So that if we say this is the technical coefficient for this economy, to ensure that all the sectors of the economy are balanced, such that we got input and we have output. A bigger challenge is when our graduates and there is no employment. So the government is doing nothing to create employment, because the output of the training institution ought to be an input of the employers or of the employment or the HR sector. But we have a mismatch. So this way we are able now to show how the resources of the economy will be shared amongst the contributing sectors to ensure that we never lack, but we've been consistently lacking. Then this helps in the, of course, determination of the gross domestic product. And also we are able to evaluate the impact of the decisions that are made in all while contributing to that national income or the national cake. We'll need to know which sector of the economy did what, or what was the technical coefficient matrix of that sector of the economy. For instance, agriculture. We expect that no one will go hungry. The whole of Northeastern, right now they are lamenting. So I don't know. So that's the purpose of the technical coefficient matrix. So what we'll do, we have different, or we'll be showing, I'll just give a case. If we were to consider, for example, two sectors of the economy that are interdependent of each other, and let's say the total output is expressed in these two equations. So I have equation 1 and I have equation 2 that is resulting into x1 and x2. If we rewrite these equations the way we've been doing as a matrix, we are going to have this matrix. We multiply by our output to get the demand. So this demand is what we are seeking to ensure that no one lacks in the economy. So in other words, if we let our A to be this matrix, A11, A12, A21, A22, and our D to be D1, this is the demand of output. So D1 and D2, and then our output is X1 and X2, then we can illustrate that in this manner. It's like we are saying our AX plus D is equals to XD, right? If that is the case, if I take XD on the other side, I want to make my X, that's the coefficient that we are looking for. I want to make it the subject of the formula, right? So what you are trying to do is to derive, this D is supposed to be here. So D, let me just enter, D is equals to X into I minus A. So if I make X the subject of the formula, I'll divide both sides by I minus A, I minus A. If I rewrite this, I'm going to have I minus A inverse multiplied by D. So our X is the total output that we desire as a sector. Our A becomes the technical coefficient matrix. And then the inverse is what we are calling the Leontief inverse. The scientist who collaborated this formula is called Wesley Leontief. That's why we are calling it Leontief matrix. Well, it is easier said. Let's have an example and see. I've shared this example on your portal. I want you to open the portal so that we work from the Excel. I'll close mine and see how we derive the technical coefficient matrix and then the Leontief inverse. Let me know when you've opened. Just stop sharing this. carried the question, I've taken it here. And read from the same page. So we've been given the input and the output of two sectors of economy, P and Q. So I have the final demand, and this is the total quantity demanded. Then I've been asked, find the technical coefficient matrix. Then determine the total output, given that the final demand for output from the industry P increased by 10%, while that of Q went down by 5. So the first thing is to get the coefficient matrix. The technical coefficient matrix. So we are looking for A. So look, we have P, and our output is 500. So we are talking of this sector of economy giving 60 out of 500, right? Then I have Q, which is 140, giving us an output of 350. Because this is our Q. So we are getting an output of 350. So our A will be 60 over 500. Then the second one is 140 over 350. Then the third one is 110 over 500. Then the fourth one is 90 over 350. You can see how we are able to get the coefficient matrix. What do you get? What is 60 over 500? Give me your answer in 2 decimal places.
$0.12.
0.12. 140 over 350.
0.4.
0.4. The third one is 110. Sorry. 110 over 500.
0.22.
0.22. Then the last one, 90 over 350.
0.26.
0.26. So this is the technical coefficient matrix. And the reason why we are getting the technical coefficient matrix, it is the A that will help us get the Leontief matrix or the Leontief inverse. Because our second one, we've been asked determine the total output given. We cannot get the total output if we don't have the Leontief matrix. And you say Leontief matrix is the identity matrix minus A. Should be in caps, minus A. So to get the identity matrix, I'm looking for a situation where I'm going to have 1, 0, 1, 0. That's the identity matrix. I subtract this matrix. Okay. Let me paste it here. And the answer that I'll get should give me now I'm looking for the Leontief inverse. Now, before I get to the Leontief inverse, if I take you back to the notes, we need to get first the, let me show you the process. We need to get the, just taking you through the process of deriving technical coefficient. Are these notes? Let me share different notes. Let me actually close these notes. They keep on confusing me. Need to have different notes. You are deriving, and I'm saying there's this step. This is where we are. So you can see what is happening. We are deriving, or we are trying to get the values of x. But before we get the values of x, we need to get the intif matrix. And it is at this point, now our identity matrix, or the 1001, is supposed to be subtracted from the technical coefficient matrix for us now to be able to get there. So you need to get the determinant, because it's the determinant that will help us. Remember, we were talking of 1 over. You can see we have d over 1 minus a for us to get the inverse. So you need to get the determinant. Let me go back. So you need to get the determinant to get our value of we are doing this minus this before you get the determinant. Can we do it together? This 1 minus this, the plus and the subtraction rule. We just subtract the corresponding side. What is 1 minus 0.12? 0.88. The second one, 0 minus negative 0.4. The third one, negative 0.22. And the last one, 0.74, right? So that is my identity matrix minus A. And we now get the determinant from that. Determinant is by multiplying the primary diagonal. Then we subtract the secondary diagonal. What is 0.88 multiplied by 0.74?
0.6512.
0.6
512.
512. Minus. Will it be a minus or a plus? Minus, because this negative multiplied by negative, which give us a positive. What do you get? What is 0.22 multiplied by 0.4?
0.088.
So what is my determinant? The determinant of A is
0.5632.
0.5632.
Yes.
So I've gotten this part of the formula. So we go to the next stage. The next stage is now getting the Leontief matrix. And you said Leontief matrix is this into bracket raised to -1 multiplied by the determinant, isn't it? But if you look at part B, we've been told determine the total output, given that the final demand for output from industry P increased by 10% and that of industry Q went down by 5%. So our output here, the final demand for P was 300. We've been told it is going up by 10%. So I'm looking at my P, or the new P. My new P is equals to 1.1 multiplied by 300. What do I get? I've increased my 300 by 10%. 10% is equals, no, 110% is equals to 1.1. Or rather, you take 110% divide by 10, it's 1.1. That will give me 330.
330.
230 or 330?
330.
Then what will be my new Q? It's now reducing. So it is 0.95. I multiply by my Q, which is 150. What do I get?
One 142.5.
142.5.
Yeah.
142.5. Well, so I now have everything to go for the Leontief matrix. So I'll start. You know how we were getting the inverse, 1 over determinant. So it will be 1 divided by determinant, which is 0.5632. Then I'll multiply by my inverse, right? And inverse, remember we said we exchange leading diagonal. So I'm going to have the exchange. So this is 0.74. I exchange it with 0.88. Then I negate the leading diagonal. It is negative 0.22 multiplied by negative, I get 0.22. This is negative 0.44. I multiply by negative, I'm going to get 0.4, right? So if I multiply my 1 over determinant, multiply by the inverse, and then PQ, which is my P is 330. My Q has given me 142.5. The answer that I'll get will be my total output. What will I get? We need to work this out. Let me bring them closer. So remember the multiplication rule. The number of rows in the leading or in the pre-multiplier matrix should be equal to the number, no, the number of columns in the pre-multiply matrix should be equal to the number of rows in the post matrix. To apply the multiplication rule. So you can do that. So I'm looking for 0.74 multiplied by 3.0, 330 plus 0.4 multiplied by 142.5. Then down here, I'm looking for 0.22 multiplied by 330 plus 0.88 multiplied by 142.5. Give me the answer. So we are looking for X. What do you get? I've said X is equals to I minus A inverse -1 by D. So this is what we've done. So we are getting the Leontief matrix, and then we are multiplying by the new demand. Yeah, all the evaluated changes in the final demand, that which increased by 10% and went down by 5%. What are you getting? It will be 1 over 0.563. Have you gotten the answer? The first one?
1.2.
3?
1.2.
301.2.
Yes.
301.2. That way.
Yes.
The second one?
198.
1?
98.
198. Multiply by 1 over 0.0 by 1 over 0.563. What do you get? I want the figures for P and Q. What do you get? One divided by 0.563. Like we are multiplying the answer by 2. 1.1 divided by 0.563 multiplied by 3 or 1.2.
534.8.
534.8. The other one?
51.56.
351
1. Yes.
point
56.
56. So that will be our total output. So we can say that sector A gave us 534.8, then sector Q gave us 351.56. Right? That is for a two-sectoral economy. There is a question I've shared in the portal. I'm going to the portal to pick it. Is that question? And these are the kind of questions that you'll get in the exam. I don't know what I've lost. It's like it has moved. This is my Z, right? This is my Y. Confirm? So now we have an economy that consists of 3 industries. So this multi-sectoral, the one that we had was for 2. Now this is for 3, or rather 3.